In this assessment, we're asked to predict which carbonyl will react most quickly with H+. Now, if we think about what H+ is, it's electron poor. It's going to be an electron pair acceptor. And so what we're really asking is between these two molecules, which is going to be most willing to donate electron density to this H+. Well, we can answer this question by looking at the Zwitter ion form of the two carbonyls, with the negative charge on oxygen and a positive charge on carbon. If we do the same thing for the ketone, we get this structure here. Now, the ability to grab that proton is going to be based on how interested this oxygen is in sharing a pair of electrons with H+. Well, if we look at the amide resonance structure, we can draw a new resonance structure that shows nitrogen donating a pair of electrons to give this. What does that mean? Well, it means two things. One, the positive charge on this carbon is stabilized through resonance, but that makes this negatively charged oxygen more interested in sharing its pair of electrons. On the other hand, for the ketone, the only thing stabilizing the positive charge is hyperconjugation. Donation by resonance is going to then make the amide more likely to grab a proton.